Okay, so this section is converting fractions to decimals. Uh, I think you're going to find it very easy. It goes very quickly. If you can use a calculator, you're going to find it even more um, like ridiculously easy. It should not take you very long. And it's one of those ones where don't stop trying this one until you get 100 on it because it won't take you very long to do them, especially if you have a calculator. If you have to do them by hand, I'll show you how to do them by hand just to make sure. We'll do a couple together. But they do introduce some vocab in this section, and you definitely want to make sure you have it squared away before you start because that's where I think you're going to get confused at. You're going to have two different types of numbers in this section. The first is a rational number. They have two characteristics. The first is the decimal repeats a pattern. That means that, something like 5.125, 125, 125, and it goes on forever. And they put the line on it over it, indicating that those numbers will continue to repeat. That's an example of a rational number. The other is the decimal will end. So if they have something like 5.3, that's what they mean by a terminated decimal, or a decimal that terminates, or a decimal that ends. The root word in rational in these problems, man, looks a little weird, is ratio. And we know a ratio is a fraction. So in other words, can you write the number as a fraction? If you can, it's a rational number. So all the whole numbers and the integers are all rational numbers. -5, -3, 10, 30, 100. Those are all rational numbers. 5.1, 5.2, 5.178. Those are all rational numbers as well. And if they give you a funky one with a repeated decimal, that's also rational. You can write that as a fraction, believe it or not. We're not going to do that, but you can. They just want you to know how to differentiate them. The other is an irrational number. That means that you can't write it as a fraction or ratio. Sorry about the bell. The decimal has no pattern. So it's just a slew of random numbers. And an example of one, everybody loves pi. If we type in pi in my calculator, you might say, well, it ends. It doesn't. The calculator's not going to go on forever. You'd never be able to do any calculations. It takes it out to the nearest, probably, I don't even know, millionth place. So it rounds it after that. But that number will continue to go on forever. Another would be like the example square root of 7. There's no pattern to that either. It just looks like a bunch of random numbers that are just tossed up there. So that's an example of a number that cannot be expressed as a fraction. So the decimal has no pattern, and the decimal does not terminate or end. So make sure you have those understood before you continue in this lesson, because when I generated my worksheet, the very first question it asks me was, which statement is true when a rational number is in fraction form is converted to a decimal? In other words, what do you know about rational numbers? Well, we know that rational numbers, the decimal repeats a pattern, or the decimal terminates. So both of those are true. So we could say either one of these would work. So if you don't understand the vocabulary, you're not going to be able to do it. If it were irrational, you'd say neither one, because the decimal doesn't end and the decimal doesn't repeat a pattern. Okay, so here's what most of the problems look like. And I'm not going to bore you to death with every single one. I'm just going to show you how to do a couple of them and let you guys have at it. So we want to convert that to a decimal. So we're going to take 16 on the outside, 5 on the inside, put a 0 there, bring the decimal straight up. That'll go, 16 goes into 50 3 times. That'll give you 48. 2, bring down another 0. 16. That's a 4. Put another 0. That's going to be a 2. 32. 8. Bring down yet another 0. And 5. So our answer, hopefully, if I did that right, is A. But we can use a calculator to check and make sure. We have 5 divided by 16, and voila, 0.312. So we're good. Okay, there's another one. So we're going to do 6 on the outside, 5 in the middle, put a decimal place. It's in this decimal place right up. 6 cannot go into 5, so if you want to put a 0 there as a placeholder, you can. But 6 can go into 50 8 times. Bring a 0. It's going to be a 3, 18. Bring down another 0. And as you can see, we're starting to get a pattern here. To no surprise, because that is a rational number. It is written as a fraction. So it's going to either have a decimal that ends or a decimal that repeats. This is just going to keep on repeating 3's because we keep getting a remainder of 2. So normally, like I kind of showed you a bad example here, you can put it over both, but Study Island just says, well, it's just going to keep repeating threes, so B is your answer. Most of the time, you're only going to put it over the first number when you see the pattern form, but that's all there is to it, so that one should not be too hard.